Welcome to the lesson on the area of regular polygons. In this lesson, we will go beyond triangles and quadrilaterals to determine how we can find the area of regular polygons. Now, regular polygons beyond four sides have a simple formula based on its simple characteristics. Now, the base idea here is that each regular polygon is made up of congruent triangles. Now again, let's recall real fast that regular means all the sides are going to be equal, all the angles are going to be equal. So for this pentagon, it is essentially made up of 5 congruent triangles. All the triangles are the same to themselves, and they're also all isosceles. This hexagon is made up of 6 congruent triangles. We draw the lines across, and we know we have 1, 2, 3, 4, 5, 6 triangles. Now, as I keep going forward, I can really see a pattern, and an octagon is going to have, as you might have imagined, 8 congruent triangles that make up its shape. And we will then use these triangles to determine a formula that's going to apply to all of these regular polygons, regardless of the number of sides. In this case, 5 for the pentagon, 6 for the hexagon, and 8 for the octagon. So then I get to the next important characteristic, and that's a new term called the apothem. Now, an apothem is the radius of the inscribed circle of a regular polygon. Now, you might be thinking, well, inscribed circle, but I really can just look at the apothem as the height of one of those triangles in my regular polygon. So I drew the apothem in the pentagon, but let's take a look at the hexagon instead and see how the apothem can really help us figure out area. And I'll do the same thing for the octagon. I draw a triangle and that apothem as its height. So let's say I remove that triangle from my hexagon. The apothem of the hexagon is the height of one of those triangles, where the side is also the base. Now, knowing that 1/2 base times height is the area of a triangle, if I could solve the area of one triangle, I can then multiply it by 6 to get the entire area of the hexagon. Now, all of those bases, all of those sides, is essentially going to make perimeter. So my formula, instead of using B and H, will be 1/2 apothem times perimeter to encompass all the sides, and in that case, all of the triangles. Now, let's go ahead and do some practice and apply this concept right away so we can go ahead and reinforce it. So in my first problem, I get an apothem of 6.4 and a side length of 7.4. So 1/2 times 6.4 times, I got to find the perimeter, so I'll do that over to the side. Perimeter is going to be equal to 7.4 times 6. That's going to be equal to 44.4. So I'll go ahead and incorporate that perimeter into my formula and go ahead and solve this expression one at a time. 1/2 times 6.4 will give me a 3.2. So then I'll multiply that 3.2 by the 44.4 and get a final answer of 142.08. That is the area of this particular hexagon. My second example, the numbers are a little bit easier. I can find out that my perimeter in this octagon is going to be 5 times 8 for 8 sides, so my perimeter is 40. So 1/2 of my apothem, which I know is 6, times that perimeter, 40, and I get 3 times 40, and that's going to give me a total area of that octagon of 120. Now let's take a look at a more complicated and applied problem. Now the park area at the right is made up of 2 regular concentric polygons and a rectangle. Find the area of the gardens that are around this picnic area and path. So I got to find what's shaded. So I'm going to find the area of the whole thing and subtract what's in white. And that'll give me the area of just what's shaded. So let's find the area of the whole thing. The whole thing is a hexagon, a big, gigantic hexagon. So 1/2, where my apothem is, be very careful, it's going to be 17 and 6, so the apothem is 23, times 120, 20 times 6. So calculating this down, my area of the whole thing is 1,380. So I'll go ahead and write that value up over to the side. And now I need to find the area of the small white hexagon in the middle. So 1/2, 6, which is my apothem, times 42, which is the perimeter of the small white hexagon, I'll go ahead and do the math from there to get a final answer of 126. So I got to find this small little path. I know one side is 7, and that the other side will be 17, just like we get from the other side. So 7 times 17 will give me the area of that small white path of 119. I combine that path with the hexagon, and I get an answer of 245. So now I'm going to subtract that 245 from the entire area, and I'll get an answer of 1,135 for the shaded region.